been asked by quite a few of the club members if I'd make a video of some of the things which I've collected, the antique radios, crystal sets and other electronic items. Well, we've put this video together, Mike Wells and myself. It's taken quite a long time to try and video it so it looks something presentable and to get the lighting and the sound right. Anyway, we hope you enjoy this program. We're going to start off with some of the very earliest items which I've collected, which are the telegraph machine, which was installed at the Rome Telegraph Office in 1863. We'll start off with the very early things and gradually build up to the sort of latest which I've got, which is probably around about the 1938-39 era. I haven't collected items after that because I find they're a little bit too bulky. So I've mainly concentrated on crystal sets, which are my favourite. I hope you enjoy this video. Right, this is the telegraph machine I was telling you about, which was installed in the Rome Telegraph Office in 1862. As you see, there are 4 items here. They consist of this switching block, which has these bars going down here with 3 terminals on the end, 3 more bars underneath going in the opposite direction, 3 more terminals there, and these contacts, which were a brass pin, and they were placed in these holes here to make contact, so you could join that wire from there onto either this bar by placing it in there, or into this one by placing it in there, so it would make contact through. It's quite a clever switching device. Now this is the galvanometer. It's all part of the same collection, all part of the same station. I don't know if you can see the galvo, I think you can there. And this of course is the device which was to lock the needle when one in transporting it. There's also just the 2 contacts on here. The Morse key is rather interesting in as much that it has this rather unusual flap here. Now the idea of that was that you could, when you were transmitting a signal, you put your hand over there and sent the signal out there. As soon as you released it, this flap come back and made contact with this switching arrangement down the bottom. So this flap in actual fact is a switch to go from transmit to receive. So when you push it forward during the transmit mode, release, and it's automatically on to receive. The machine itself is quite an interesting machine, all brass with a glass plate top to it so you can see the works inside. It's actually operated by 2 solenoids which are over the back here. We'll try and show those to you in a moment. And as the solenoid was energized, it released this brake here, brought this contact here up and down, which marked the paper as it was going through, being pulled through by these rollers, and marked it in dots and dashes. So that's how the signal was read off on the other side of the tape there. There's not much else I can tell you about it, except that I haven't restored it as yet. It's going to take a long time and a lot of work to restore this particular machine. It's one of 2 which I have. I'll show you the other one shortly, which is the German one. This one is Italian, and there's not much else I can tell you about it. So we'll try and show you some of the inner workings of this. This is the label which is stuck in the bottom of the Morse key, and on it it has Office Telegraph Roma. A of the Roma is missing, or it's folded over in fact, but the date is quite clear there. It's 1862, the 7th month 1862, and the signature of the 2 people who either repaired it or installed it or whatever. But that's quite interesting. The same type of label is also on the bottom of the telegraph machine. I'm not sure if it's the same person who installed it though. Well, this is the inside of the telegraph machine, and I was telling you about the solenoids, where here they are, two solenoids, and they pull this bar down, and when this bar goes down, then you can see all the sort of things happen when it's switched on. This sort of thing goes up and down here, which activates that lever over there, and you can see the air brake here. You made me jump then. But very, very nicely made, beautifully engineered, and I'm sure it took someone a long time to make this. But there we are, that's the telegraph machine actually working. There she is in all her glory, the wonderful telegraph machine. As you will see with the next one, the Siemens-Halske one, which we'll show next, the layout and construction is quite different, but of course it's clockwork still. So there we are, the telegraph machine. Well, this is the German machine, the Siemens-Halske machine, which is quite a nice one. It's quite different from the other machine, as you saw. We'll just let it go around so you can see a full view of the whole thing, and then we'll do a few close-ups and show you the workings of this particular machine. And you can see the tape comes out here, up round through this part here, over the rollers, and in a moment we'll set the thing going to show you how it marks the paper. It's rather a unique way of doing it. When it comes round on the other side, I'll stop the machine and let you see that. Here's the terminals, which all the incoming wires were connected to. The two solenoids over here, and they're nice brass cans, and that was, they would pull down this bar, which would activate the mechanism and start the thing going. So it was a fully automatic system, this one. There's a little window in the top here that you can see the amount of paper left in the machine, because inside here there's a tray with a big roll of paper in it, which comes out through here. Now, the way this machine operated was that when the solenoid was activated over here, pulled down, this tape started pulling out through here and being fed by these rollers. Now, this little ink bath here has a wheel which is half submersed in the ink, and as the solenoid is activated, it brings this wheel up, as you can see, just raising it and marking the paper with the dots and dashes on it there. So it's rather different from the other one, which had like a carbon pencil lead which marked the paper. There we are, we can clearly see the drawer now, which comes out the front with the paper spool in here. And as you can see, it would carry quite a lot of paper, so you get quite a lot of messages, I should think, on that reel of paper. And this just went back inside there, through that little slot there at the end, up, pulled the paper up, down through here, under the top part, a bit fiddly this, but then underneath there, lift that up there, and the whole thing was in position then. And then of course we got it ready to work. Well, here's the inside of this machine, and if we press the solenoid down, we should get it to work. There we are. All the time it's working like that, or receiving a signal, the thing will keep going. But as soon as we stop the solenoid working, then the machine automatically stops. That's done by this little tiny bar up here. You can actually see that. There's a little groove in that part of it there, and all the time the solenoid's going, you can see it's facing down, and this bar that's going round misses it. As soon as you let go, then the thing will come round and stop against it, which stops the machine. So there we are, that's the Siemens-Halske machine. Right, this is probably about the most interesting Morse key that I have in my collection. I don't have many, it's not a thing I've really gone out to look for, but sort of just come across them, and some of them are quite interesting, but this is probably the one that goes with the telegraph machine, so I've been told. It's a GPO key. It's been around for a long time, about 1918, that's the first time it was seen, I believe, with a galvanometer, which was part of the telegraph set, and also the buzzer, which I have, which we'll show you in a moment. We'll do a few close-ups of this in a moment because it's very, very well engineered and has one or two features about it which the other Morse keys do not have. So let's just have a look at that. Right, the Morse key we have here is the GPO one, which has got this glass top to it, cover to keep all the dust and things out. So we'll take that off and we can see it a little better inside. The action is very, very nice. As you can see, it's double contacts here, rather here and over here, double contacts with many, many adjustments on them. And a very, very nice action this key has. The send-receive switch is down here. You can probably see it here, send and receive, which does the changeover. Very, very nice action on that. So there we are, that's a GPO Morse key, which was commonly used in the very early days apparently. Well, here's the underside of that key. As you can see, none of your flimsy wiring stuff here, it's all in solid strips with quite a few nuts and bolts in it, and quite a heavy key, this one. It's a very weighty device. So there we are, that's the Morse key, the GPO one which I have. Right, this is a buzzer of the same style as the Morse key, with a removable top cover. I found this one along St Leonard's. The chap was using it as a paperweight, and I persuaded him that I could make better use of it than what he was. And there we are, as you can see, very, very nicely made inside. The buzzer with the little adjusting screw on the side. So that's part of the set. There was 3 items in the set as far as I know: the galvanometer, and the Morse key, and this buzzer, and that was part of the GPO set. Well, here's another very heavy Morse key, quite well made. There's no make on it at all, so I'm not sure who made this one, if it was a home brewed one or not, but it's quite well made, and the underneath leads me to believe that it wasn't a home constructed one. Here's a pretty standard sort of Morse key that was around in the early days, and this one is actually manufactured by A. Mason, Belmont, Surrey, Sutton, and it has a telephone number, a 3-figure telephone number there. Quite a nice action key, this one. I don't know if we can see the underside of it, but all the holes are filled up with wax, and where the wires went, they're all covered in wax. This one's a rather nice little key. It's made by A.W. Gamage, Holborn, London. EC, that's what it says on it. And quite a funny little button on the top here, a little red button. I take it that that's original, but that's how I found it anyway. And the underneath, as you can see, has the wires buried into the wood there. But quite a nice little key, this one. We can clearly see now the A.W. Gamage badge on this key, and of course Gamage's done a lot of Morse keys and radio parts in the very early days, crystal sets and other radio kits, and I take it it's the same Gamage that's still going now. There's a shop in Hastings called Gamage's with toys and that sort of thing, so I should imagine it is probably the same. Well, this is the only military Morse key I have. It's an Admiralty pattern Morse key, so it says on it, and a nice action key, this one. Quite a heavy duty one. On ebonite, I believe this is, or bakelite. It's rather thick, and there's the underneath of it. And you can see quite a well-made Morse key. This is the Admiralty Morse key with the Admiralty pattern number here, and also it's quite interesting to see that this Morse key also has a serial number underneath there. Right, this is rather an unusual Morse key. It's from an aircraft spark transmitter. It was found locally, and this is one that I have taken apart and thoroughly cleaned and put back together. Well, here's a bit more of a close-up of this spark gap Morse key, and you can clearly see the spark gap here on the Morse key itself. I suppose it's quite a dangerous key to use, this with high voltage on it. It would have had a cover that went down over this part, a metal cover going over the whole key, which I haven't managed to find. It wasn't with it when I discovered the key, but it's got quite a nice action on this key, and we'll try and show you a few more close-ups of the workings of this particular device. You can clearly see the very heavy duty contacts here, probably a platinum that I used to use in the early days. The other end of the Morse key, you've also got these contacts and adjusters here. There's 3 adjustments on each contact. One here, and one here, and this one here, giving you the height. This is a photograph I took of the Morse key when I stripped it down and cleaned every part in it, and there are 62 parts in this Morse key. Right, there we are. That's a nice close-up of it. The connections to the key were made through these holes in the side here, and 2 more at the back. The ones marked at the back are R and R, and these, as you can see, are E and E. I'm not sure what those 2 were there. Those 2 there are. They're not marked, in fact. Well, here we are. This is the man who started it all, Marconi, and I'm very pleased to say that I have one of his very first transmitters, the spark transmitter, which is what we'll be showing you now. Right, well, here we are. This is the device. It develops many thousands of volts which appear across these 2 spheres here. That's where the spark is adjusted by these 2 rods. You can get up to, I've had it going up to about 4 inches, the spark on this, which is quite frightening to think that it's probably well over 100,000 volts generated in it. This is basically what we call the Ruhmkorff coil, designed by Ruhmkorff, of course, and that's basically what the spark transmitter was designed around. We'll go in and show you some more of the parts of this transmitter in a moment, but basically the switch here is a polarity reversing switch, and of course this is where the vibrator part here. The contacts here are platinum contacts, and the primary of the coil comes down here onto this terminal and that terminal over there, and with a few more terminals around here which we'll explain in a moment. Right, this is the polarity reversing switch, and it's made of ivory. This is solid ivory in the centre part here with the ivory bar for the switch. Just 2 contacts, and which have got the negative and positive on it, and the other is taken off these feeds here. It's from there up to there, and from that one up to the other one, and depends where you turn it, of course, if it's negative or positive on there. So the battery, which the whole thing runs on about 5 or 6 volts, comes off here, and then down to the Morse key, which is on these contacts over the back there. We'll try and run this thing in a moment, and hoping it doesn't upset the camera too much, and also block out half the radios in Hastings. Well, there we can see the rear part of the machine, and over here it has this chain with a little switch bar on here with an ivory handle to it. This is the original switch. This was for switching out the capacitor, which is built in to the base of the transmitter. The whole length of the transmitter and width is has a rather large capacitor. Sort of looks like homemade. It's just foil, then wax paper, then more foil, and squeezed between 2 pieces of plywood. And that is a very large capacitor, which this is switched in and out by this switch here. The other adjustments here, this one is for the tension of the hammer, this part here, which vibrates backwards and forwards at a great rate of knots, and the further adjustments over here for the contact when we get a little bit of sparking on that there. That's for doing the fine adjustment there. And this apparently are platinum contacts on this here, and quite large though. Well, here we are, we've got the thing ready to fire up. In fact, I've got a battery, a 6-volt battery here, and a Morse key, and we'll attempt to wire this up and see what we can get out of this spark transmitter. As it radiates for quite some way without an aerial, I won't use my call sign when I test it, in case someone's picking it up. And this is one of the terminals into here, and the other one somewhere around there. I can stretch that bit of wire to it, and there's the polarity switch there, so we'll put that on there now, and we should be somewhere. We might have to adjust the thing. Let's try it. Well, that's alright. Yes, well, as I said, we didn't want to use my call sign, did we? I wonder if you could pick that one out. We'll do it again. In fact, I've got a radio somewhere here. Let's have a listen to see what the note sounds like on the air. I don't think it's going to be very selective of where we tune the radio, especially at this distance. Probably a bit raucous, I should think. Yes. Well, there we are. There's a demonstration of the spark transmitter. And what we will do, we'll adjust these rods out just to show you how far or what size spark we can achieve. At the moment it's about just under ½ an inch, I should think, which is the normal position or distance they had these spark transmitters running at. What would they do is connect the aerial on here and the earth on here. We'll show you a picture in the book in a moment to show you how one was set up. But what I'll do, I'll just adjust these out and we'll see what sort of distance we could get. I'll be a bit optimistic there, I think. Oh, good. Let's get it a little bit further, perhaps. Well, it's we might do by fine-tuning this. Well, there we are. That's a good 3 inches there. But they never run them at that distance. It was always close together. I was remembering not to put my hand on that key when I'm doing this adjustment, because that wouldn't be very nice. There we are. Demonstrated the spark transmitter. This transmitter dates back to about Around about the 1900s, I should think, 1901, something about that era, according to the books that I can find pictures of and the dates that they're given. Most of the ships carried these spark transmitters as a backup transmitter up until, I say recently, probably about 30 years ago. Certainly in the wartime they were using spark. Right, well, we're going to give you a bit of a close-up of this spark, if we can, and let you see a much better view of it. There we are, that's quite a nice view. We'll extend them out. There we are, that's given you quite a good view of the length of spark. It's about 2.5 to 3 inches gap there at the moment, and quite impressive. This book has quite a few interesting pictures in it, which I'll show you in a moment. But there's a book I found at a boot fair, and it's called The Romance of Modern Invention, and has quite a lot to do, or show rather, of Marconi's exploits in the very early days, with quite a few facts. And let's have a look here now. This picture here is a corner of Marconi's cabin on board SS Minneapolis, showing instruments used in wireless telegraphy. And you can clearly see one of these spark transmitters, or two of them in fact, sighted rather, in the cabin. Here you can see one of the transmitters on the side here, with the two little posts and the two brass balls there, and the two wires from those two posts going off out to the area. Well, probably one's going to an earth, I should think. But it's quite a nice picture. There's another one over there, so they had a standby one as well, and a few other bits of apparatus kicking around in the radio cabin there. Here's another picture of Marconi's travelling station for wireless telegraphy. It looks like a chimney, that on top of the vehicle, but it's not. In fact, it's the aerial. A few other interesting facts here in this book is that the distances they achieved with these spark transmitters in the early days, we're talking about 1897 up to about 1901, Needles Hotel to Swanage 17.5 miles, Salisbury to Bath 34 miles, French coast to Harwich 90 miles, Isle of Wight to the Lizard 196 miles, and at sea in 1901 350 miles was achieved. And of course December the 17th 1901, England to America 2099 miles. So this book was quite a good find from a boot sale, The Romance of Modern Invention by Archibald Williams. Quite a few photographs in it, and some quite interesting information. I also have another book here called Radio, and that tells us and shows us a little bit more about Marconi's achievements and the apparatus he used in the very early days. In fact, we've got a picture here of Marconi's setup. It's a model, in fact. They've made a model up of what he used in 1895. Here's a picture of Marconi's apparatus, and it says here, model of Marconi's experimental transmitter used in Bologna during the summer of 1895, showing the spark gap, induction coil, and an elevated copper sheet aerial supported by a bamboo frame. So that was his first setup by the look of it. Well, there we are. We've covered quite a lot with the spark transmitter. The thing is that, of course, what was he receiving this on? They used coherers, which were invented by Bradley. It's called a Bradley coherer, which was a glass file tube with filings in between two contacts. And what they found that when placed fairly close to one of these spark transmitters, the filings would short circuit the two, or make a different resistance between the two contacts at the end. And so that's what they were receiving these on, and they were mainly using it for switching, not for receiving sound, but it was actually ringing bells and sounding buzzers and that sort of thing. So that's what they were using for the receiving side. I haven't got a coherer, unfortunately. I'd love to have one, but they're pretty rare, as you can get. Well, now we come to my favourites, the crystal sets. And we've got about 15 here altogether. Some have been restored, some haven't. And some of them it's going to take a long time to do, but we'll show them to you one by one and show you the different features on them. Well, this is a Jeckerphone crystal set which I discovered recently in a second-hand shop under a pile of rubbish, and as you can see the state it's in. It's complete with all its cobwebs. The cat's whisker has been replaced by a piece of 24 gauge wire by the look of it, and it's a pretty sorry state. There's no glass, that's gone. There's no bridging bar for the coil which would normally go in there, but luckily it's got all of its transfers. The Jeckerphone transfer is there, and also the BBC transfer on the back here, British manufacturer transfer. So it's all there except for the glass. It wants tidying up and cleaning up, and we'll show you now what this looks like when it's been restored. Well, there we are. By some fluke you can see what it looks like when it's been restored. All the terminals been found, the correct ones, and the proper bridging bar here, and of course the cat's whisker all been replaced with the proper cat's whisker and crystal in there, and you can see the transfer has come out quite nice, and so is also the BBC badge on there. Right, the set proper name is Jeckerphone Junior. It's made by the General Electric Company in 1925, and it has the BBC and stroke EBM, which is entirely British manufacturer's stamp. It's for use with headphones only, of course. Has a glass enclosed cat's whisker, a galena detector, variable condenser tuning, medium wave 300 to 500 meters, plus provision for a long wave tuning coil. That's on that link at the back there. It's nickel plated fittings on a mahogany control panel and base, and the cost of this was 16 shillings. Well, this is an interesting crystal set. It's one I purchased from a friend of mine down at Bournemouth who's a collector. It's a Brownie wireless crystal set, and it came on the market in early 1924, and it has the BBC stroke EBM stamp on it. I've also got this complete with its original box, cardboard box, which has got some rather interesting writing on, which we'll show you, and also the little tiny box with a spare cat's whisker and crystal. The base of this is detachable, and it was sold separately, which I have the base, as you can see. This part came off here and goes back into there, and that was, as I say, sold separately for an extra 1 6, I believe that was. This crystal set is in extremely good condition. I have renovated it. I've had all the metalwork replated. But what is nice about it, that the writing, the transfers are all intact, nothing missing at all. Extremely nice. The other features on this set are the shorting link here, which When you remove that, you used to plug in a coil which extended the range of this coil to the long wave band for the time signals which were sent from Chelmsford and also from Paris. The transfers on here, as you can see, are extremely nice. The tuning was achieved by sliding this shorting bar up over the coil, and the contact was made between here and the coil. This is the earth connection on the top here, so what you were doing was virtually shorting the coil down to earth, and that gave it its tuning range. There's a close-up of the detector itself and the little cat's whisker. The headphones are on here and here. As I told you before, that's where the coil went for extending the range to long wave, and the aerial connection was made on this terminal here. It's interesting to note that the picture on the side of this crystal set shows the open crystal detector, which was the model they made in 1923. Well, this is the original box that the crystal set came in, and it's got some rather interesting writing on this, which we'll try and show you. But it's very unusual to find a set of that age in its original car. Well, here's some of the claims which they've been brave enough to put in writing on here. It says here, this voucher guarantees the Brownie wireless sold herewith to operate under the same conditions and to equal the results obtainable with any crystal receiver retailing up to and including £10. Money will be refunded in full if the Brownie wireless fails to do this and is returned undamaged within 1 month of purchase. Name and address of supplier and the date. So quite a nice little guarantee, that. This is the little box that the base come in, which was sold separately. There we are. There's some of the interesting writing on the box of the base. Well, here's the little box which has got the two palladium cat's whisker and the two crystals in it, like a little pill box made of cardboard. But it's very nice to find the whole 3 items, the original box, the box for the base, and also the box they gave you with 2 more spare crystals in. There we are. There's the 2 pieces of galena that they supplied with the crystal set. The crystal set sold in 1924 for 7 and 6pence. That was the body only. The base was an extra 1 and 6pence. So the total cost of the whole unit, including the 2 spare crystals, was 9 shillings. Here we have 3 interesting crystal sets made by BTH, British Thomson Houston Limited. The one on the far right is called the Type C Form A, made in 1922. The one in the middle is called the Beiju, and made in 1923, and also made in 1923 was the BTH Radiola 1 Type VC Form B. This one has a valve amplifier incorporated in it. We'll have a close-up look at them because they're quite an interesting range of sets, these, and they're the only 3 crystal sets, or the type of crystal set, that BTH made. Well, this is the BTH Type C Form A, made in 1922. It has the BBC PMG stamp. Now, they started issuing this in 1922 to show that the equipment was actually approved by the Postmaster General, and it would have a GPO registration number, which we'll show you in a moment. But another interesting thing about this model, I think, is about the first one that come out with two crystal detectors, one here and one on this side, two adjusters here, and also a switch here for changing them over from crystal 1 to crystal 2. The top part here is a bridge again for inserting the long wave coil. You take the bridge out and place a coil in there so that you could receive the time signals from Paris and also from Chelmsford. Aerial connection down here, and the headphones are over here. With this shot you can clearly see the twin crystals, which is rather unique with the BTH crystal sets. You have crystal 1 and crystal 2, and you can probably see the cat's whisker moving about there, and once to place it just gently onto the crystal, then do the same on the other one, and then you could switch to see which is the best reception between the two. This is the tuner control over here, which tuned the range from 300 to 600 meters between 70 and from 0 rather, right over to 180. It depends whereabouts. If you had the Paris coil fitted, the extra long wave coil, where the tuning was, of course, and that's where the switch come in, which I shall show you in a moment, for the different positions. Here's the switch I mentioned, which alters the range. At that point position there, you're covering the medium wave, and also the bottom end of medium wave there. When it was turned to P, that was for Paris, when the other coil was inserted, and in actual fact what that done was short out the capacitor inside, which we'll show you on the circuit diagram in a moment. There's a picture from a book showing the Paris coil fitted, and also with the BTH headphones, which I have got quite a few pairs of the BTH headphones. Here's the circuit diagram of the BTH Type C, and as you can see, it doesn't have a tuning capacitor, it has a variometer. The aerial comes in here, down through here, and on that switch which we select, which I showed you just now, the S, off, and the P position. In the P position you can clearly see that the capacitor here is shorted out, and the aerial goes directly in onto the variometer. The twin crystals are over here, 1 and 2, with a capacitor across the headphone terminals. Here's a close-up of the BBC/PMG stamp, which all these sets manufactured between 22 and 23 had to have this stamp on them to say that they were approved, and that's rather a nice one. Here you can see the BTH trademark, which was used on nearly all their sets, I believe. Well, certainly on all these 3 crystal sets which I have, and probably on a lot of their other products. And that was just underneath the carrying handle on the lid. Now we can see the wireless crystal receiver badge, which of course is British Thomson Houston. That's fitted on most of their sets as well. It also gives the serial number of the radio, which is R3037. Well, there we are. That's the BTH Type C. This set sold for £1.15 plus 7 and sixpence BBC royalty, which had to be paid on all crystal sets manufactured between 22 and 24. So that's one of the range. We'll have a look at the next one now, which was manufactured in 1923. Well, this crystal set is the Beiju crystal set by BTH, the middle one which we showed you. And this one sold for £1 plus 1 shilling royalty to the BBC. It's quite a nice little set. In fact, we've had this one going this afternoon, and we'll hook it up later on and let you hear what it sounds like. Of course, unfortunately, in the evening there are so many stations on that we're going to get about 20 stations, as you'll hear shortly. But we'll do a few close-ups on it and let you have a look at some of the features on this particular model. Well, we can see here that the headphones are made on this connection here, the telephones. The earth over here, aerial, and this switch here is to alter the range. It has a tap on the coil inside. It's a variometer tuning on this one. And the crystal is a galena crystal, but it's completely open. It's called an open galena type of crystal. The tuning range of this goes from 300 meters to 450. Right, we'll take the aerial now, an earth, and couple the crystal set directly into the videotape recorder in sound input so that we can hear what's going on medium wave. I should imagine at this time of night we're going to get a lot of stations all jumbled up together. When I listened to this set earlier today, it was quite good, as I was just able to tune the one station at a time. But the selectivity on these sets is a little bit to be desired, as you'll no doubt see, or hear rather.
Herzlichen Ansichten. La base. Das waren die Nachrichten.
Benny Lattimore from an album called Slow Down, came out in the States on Monaco last year. It's called All You Need. Coming up from Darlene Love.
Well, there we are. We heard the medium wave all together by the sound of it. There's the inside of the lid of this little crystal set. As you can see, it's got the same badge as the previous one, the British Thomson Houston Company Limited badge, and also the full instructions for how to tune it and what sort of area you require, and also the tuning range. There we are, that's a little Beiju crystal set by BTH. Brilliant. Right, well here we have the sort of Rolls Royce of crystal sets, the BTH Radiola 1. This one is valve amplified, made in 1923, and it has quite a number of features on it. But it is a real superb, one of the best crystal sets I've got for the domestic side, with twin crystals, as you can see, and a very nice cabinet, mahogany cabinet, which I think all the BTH sets were made with mahogany cabinets. The tuning range is from 300 to 600 meters, and of course it would have a battery. It has a 1-volt battery for the valve, for the filament, galena galena crystals detector, and we'll show you a little bit more about this one with some close-ups. Well, here we have the telephone connection, or the headphones in other words, but they call them telephones, the twin crystals here, and the switch for the two crystals, switch from 1 to 2. This is the tuner here, and also the provision for adding the extra coil for the long wave station. That also has on the other tuner, there's two tuners in this, as if it's an RF stage. Also we have up here another provision for adding the extra coil, aerial connection over here, earth, and here we have a rheostat for the filaments, and also the little holes over here so you can actually see the filament glowing in the valve. The accumulator goes across here, and the switch of course for the ranges again. There we are, there's a nice close-up of the twin crystal detector with the two cat's whiskers there. Quite a nice fine adjustment you've got on these. The scales on these sets are made of ivorine. That's this part here. And quite a nice fine adjustment you've got on there. That's tuner B. Here we have tuner A, same type as B of course, with the bridge across the top for the other coil to go in. There's a shot of the top panel of this receiver. There we are, quite comprehensive instructions for running this crystal set, with all sorts of advice and one thing and another, and the length of aerial they recommend is 100 foot. The valve used in this is a BTH B5 valve, and it has 0.06 amp filament current. What else can I tell you about it? Not a lot. I think the HT runs from about 30 or 40 volts, quite low in fact. There we can clearly see the registration number of this set, 0373, and of course it's type approved by the Postmaster General. Here's the rear of the crystal set with a nice little door which opens so you can get at the battery and at the valve, and of course the leads here for connections. There we are, there's the valve removed. There we are, there's a shot we've got of the inside of the crystal set, and you can clearly see the two coils for tuner A and tuner B. Well, there we are. There's a circuit diagram of the BTH valve and crystal circuit receiver, and it's a reflex receiver. As you can see, the aerial is amplified here, but it also uses it as an LF amplifier and is reflected back into it. That's why they call it the reflex circuit. And you've got the tuner A here and tuner B in the anode of the valve. The twin crystals, of course, are over here, switched 1 and 2, and the battery supplies, telephone. Also the rheostat here for the accumulator, so you can vary the volume possibly by altering the filament. So there we are. There's the BTH Radiola 1, made in 1923, and it sold for £11. That was including the HT battery, so quite an expensive set. Right, well, now we've come to what I consider the interesting part of the video. These are two military sets which I have, one American and one English. One's made by Marconi and the other one by DeForest, and they're around about 1916, 1918. The American one is about 1918. We'll have a close-up look at those shortly, but first off, let's just have a little talk about the crystal sets as they first come about. In 1906, the first crystal receivers were developed. In fact, Professor Braun, a German, patented his crystal detector on February the 18th in 1906. And in February the 21st, along comes Dr. L.W. Austin, who developed the silicon crystal detector. And he patented that. And then, of course, in March of the same year, along comes General H. Dunwoody, an American, who invented the carborundum detector for crystal sets. It's interesting to know that in 1906 there were 68 amateur experimental licenses issued, and 1907 Lee DeForest, he painted his first 3-electrode valve, which was a triode, of course. And also in 1907 the new development of crystal detectors come along, one called a Perican detector, which was the name was derived from perfect pick and contact. That's how they got the word Perican, which stayed around for quite some time. And that patent was applied for that in 1907. In 1906, again going back there, the world's first wireless telephony broadcast took place in America between Brant Rock and Plymouth, Massachusetts, a distance of about 11 miles. And that was the world's first telephony broadcast. In 1908, there was a big development. New high-power Navy stations were coming on the air, 5 kilowatt ones. The first one was at Horsey near Portsmouth, and in 1909 they got going with a 100 kilowatt transmitter, Navy one, at Cleethorpes. 1910, of course we know that Dr. Crippen was arrested at sea. What else happened in 1910? Gamages sold their first kits for the amateurs, which was a little spark transmitter and a receiver, and that was sold as a little kit in 1910 by Gamages. 1911, Marconi carried out his first air-to-ground radio experiments at Hendon Aerodrome. 1912, of course, sinking of the Titanic. Well, we know what part radio played in that. Not a lot happened between 1912 and 1914, except for, of course, the war come along, 1914. And, of course, that's where these appeared. Now, these were classed as shortwave receivers, and were sold after the war as government surplus, but they weren't any good for receiving because the broadcasts were on completely different bands. They were much lower frequency than what these things were for. So a lot of people bought them, thought they were going to receive the broadcast bands on them, but they couldn't receive anything at all. And that's because there's nothing going on there except military stuff, of course. These sets, they tune, the Marconi one, in fact, tunes between 100 and 700 meters. And I'm not too sure this one here, and we will go into it in a moment and find out what it does tune. Oh, wavelength 200 to 600. It does say so over there on the tuning chart. There's quite a lot of things to see with these two crystal sets. As you can see, they're quite comprehensive with buzzers and various other things, but we'll talk about those shortly. In 1918, that's when this one was made, and it's called the BC-14. As you know, most American stuff equipment starts with a BC number, and that is BC-14A. And this one, of course, is the Marconi shortwave set Mark III tuner, made by the Marconi Wireless and Telegraph Company. What else happened? 1922, the first broadcast took place by Marconi from Chelmsford, and he went out of the course on a 2MT. That was mainly broadcast for amateurs, so they can get tuned up and had something to listen to when they've made their sets. Then, of course, after that, the domestic crystal sets come along, and they were in abundance from about 1922, and they finally petered out at about 1927. So that was the era for the crystal sets. Anyway, we'll have a look at these one at a time, and as you'll find, they'll be quite. The Marconi shortwave set Mark III tuner. It's covered in its original sort of green, dark green Rexine. The box is mahogany. The little box here is for the cells, 2 batteries go in there, and they operate this buzzer over here. Now, it had a buzzer so that you could set the buzzer going and tune the coils and the aerial to resonance. There are 2 detectors, the Perican detector there and a carborundum detector there. Switching here for the valve or Perican, that was 2 terminals that went out to a valve for amplifying, and this switch, when it was thrown over in this direction, was for the carborundum detector. Aerial tuning capacitor here, closed circuit condenser here, and the one over here was the coupling for the aerial circuit. A nice switching there. Sorry about the bird noises in the background. Watch over here for timing the messages, and the charts here: station received, the wavelength, condenser setting, inductance setting, closed circuit and aerial circuits, and of course the full instructions up here, including the circuit diagram. Right, we'll show you this in a little bit more close-up detail. Right, well, in the lid itself, as I mentioned, you have a watch for timing the messages, and also this little box here has the full range of all the different types of detector that you could use, which is quite interesting to see that it's got its complete set there. Well, here we've got the different types of material used for the detector. That one there is carborundum. Then we have galena, zincite, borite, brookite, chalcopyrites, black tellurium, and anglesite. So quite a number of different materials they use for the detectors. Here we've got the circuit diagram for the shortwave tuner. As you can see, it's a little bit more interesting than the ordinary standard crystal set. Here we've got the buzzer, and there's the 2 tuned circuits. The buzzer battery down there and the potentiometer for varying the volts on the buzzer. And then we've got the output to the valve and the aerial tuning circuit there. The closed circuit condenser, and this part down here you've got is the detector, the Pelican one. Here we've got the continuous black line is the oscillating circuits, the dotted line is the buzzer testing circuits, and the other one is the detecting circuits. There we can see the Marconi Wireless Telegraph Company Limited, London, the manufacturers of this set. There's the Pelican detector, where the adjustment was made by turning the control round there and getting a different contact face to face, the two different materials. There's no cat's whisker in this detector at all, in either of them. So that's how the detection was made. There's the carborundum detector. In fact, you can just see the little round disc there with the piece of carborundum. You can't see that, but it's mounted underneath that plate there. But you unscrewed that, of course, and changed it for different types of detector. There's the changeover switch. Note that it's got a standby position on this. Tune and standby. Here we've got the coupling for the aerial circuit. In fact, you can see loose coupling in that position and tight coupling there. The switch above, of course, is for the aerial tuning circuit. Quite a heavy duty brass switch. You'd think there was a lot of current being passed here, but of course there wasn't. There's the aerial tuning inductance, a very heavy duty brass switch. Now here's the buzzer underneath here. There you can clearly see the little buzzer which we tune for resonance. That was going into a circuit which sent the buzzer up the aerial, so you could tune the rest of the circuits for resonance. It's quite a handy little gadget to have on there, I suppose. In case you couldn't hear a signal, you could tune the whole thing up before you started seriously listening. Here we've got the changeover switch, the battery switch, and there's the buzzer key for turning the buzzer on and off. The aerial condenser and the closed circuit condenser. There's the potentiometer, which you saw on the circuit diagram, for varying the volts to the buzzer. There's a little sign there, of course the government sign, the little arrow. Well, there we are. There's the crystal set. The Marconi one, the little battery container there for housing the batteries for operating the buzzer, all in a nice little mahogany box built in. The other compartment above, of course, is for the headphones, and a nice big thick heavy duty carrying handle, leather one on the side there. Quite a weighty thing to carry around. These were sold government surplus in 1920, I've seen adverts for them, for 19 and sixpence. Quite a bargain. Of course they're worth a lot more than that nowadays, as you can well imagine. Well, here's the other military crystal set I have, the American one, and this one is a BC-14A made by DeForest, American company. and I don't know quite how this arrived in this country or what it was used for. I didn't know the Americans sent equipment over here for the First World War, but obviously they did. It comes complete with its headphones. I've not restored it at all. It's in really wants a good clean up, but it's just as I found it at one of the antiques fairs at Ardingly, in fact, this one. And it's in fairly good condition, doesn't need too much doing to it. A little bit out of the cabinet on the side here, but we can get that put back in. It is complete with its circuit diagram. And we'll have a close look at this. It's quite an interesting crystal set. Not quite so complicated as the Marconi one, which we saw previously, but it's still of great interest. Here we are, Signal Corporation, US Army, radio receiver set box, it says. Type number BC14A, the order number it was ordered by, or the department or something. And the date, September the 12th, 1918. And made by DeForest Radio and Telegraph and Telephone Company, that would be New York. Well, here we are. This is the DeForest crystal set. We've got on this a secondary tuning over here and the primary tuning on this side. Here's the cat's whisker and the detector, and it's rather a large device. It does in fact come apart. We can unscrew this and the whole thing comes out and goes in a little box at the back. But the crystal, the actual cat's whisker is enormous. I've never seen such a large cat's whisker made out of about 24 gauge wire. The telephone or the headphone terminals are over here. Here we've got taps on the coil. It says T and AP. It's also got a buzzer, the same as the Marconi one, for tuning up on resonance, to get resonance rather in the aerial circuits. And that's over here, the buzzer. Aerial and ground. And here we have, of course, more taps on the aerial tuning coil, and coupling over here, so we can couple the two circuits together, the primary and the secondary, and we can vary the coupling on this control here, and another control here with taps, of course, on the secondary. So this one will be for the primary winding, the taps on the coil, and the secondary winding taps on there. Here we have a switch for push or on for the buzzer, and that would operate the little buzzer which is in here. Here's the circuit diagram, the aerial in here, ground, and here's the primary circuit here with the taps on the coil. The buzzer circuit is here, and its little battery, and was injected into the aerial circuit here. There's the coupling into the secondary circuit, which is tapped again, of course, and down here, a modern telephone jack there. And the crystal detector is over here, and that's the output. Down below we can see the frequency or the wavelength which it covered, which was 200 meters to 600 meters, and it gave you here all the inductance tap and the condenser settings. Well, here's the instructions. Not quite so complicated as the Marconi ones, but still quite a lot to do to get a signal out of this. And it tells you to set the indicator so many degrees for tuning one station and one thing another, so quite complicated really. Now we can see that crystal detector and the enormous size of the cat's whisker there. As I said, made out of about 22-24 gauge wire. This little part down here holds the crystal firmly in place, Galena crystal I believe. This set doesn't have a selection of crystals like the Marconi one, just relies on that one. Quite a lot of brass on this particular one, all brass fittings everywhere, no nickel at all. This little box here is for the crystal detector to live in. I think it must have had a second one in here as well, but as I say, I've only got the one with it. But I think that's what that was for, and the battery which operated the buzzer would have clipped in over on this side of the box. That's also the headphone compartment there as well. Well, here's the inside of this BC14, and the huge airspace tuning capacitors here. Very, very nice. Aluminium plates with brass ends, and the inductance here, the inductive coupled coils, as you can see. This over here is a fixed capacitor. In fact, I think it's about 3 in there, moulded in pitch, and the 2 output jacks for headphones, multiple headphone output. So quite a nice set, and one that's just begging to be restored. And there's the little buzzer. We'll take the cap off, and you can see very, very good condition with the little adjustments on here and over here. Right, we've got a little collection of crystal sets here, which we'll have a close-up of. Some of them are quite interesting. First off, we'll have a look at this one, which is a little cheap crystal set. The type of thing was sold by Wars pre-war. Here we can see quite clearly the little crystal detector. This was sold as a kit, and you just put the whole thing together. All the nuts and bolts were supplied. It's all brass here. Headphones here and here. Aerial and earth over there. Quite a nice little crystal set. This is an unusual little crystal set. It has the BBC stamp on it, approved by the Postmaster General, and it was made by S.J.H. Wilkes of Stetchford. The headphones here, the earth, the aerial over here, and this was a tap on the coil so that you could add the long wave to it. The tuning on this was achieved by pulling open this door. The coils are embedded here and the other one over here, and what you've done to tune it, you pulled this door round and tuned it like so, and that's how you've got the tuning. Very, very unusual set, made of mahogany, the box, and quite an unusual one. We can see the coil, very nicely made, sort of embedded in the woodwork here. It's wax so it doesn't fall apart, and inside you can see it's pretty simple. All you've got is one capacitor over here and the connections from the coil. So that's rather an unusual crystal set. This is a nice little crystal set. It's, the only thing I can find out about it is that it's got JR written on it, or printed on it in fact, and I picked this one up from a antiques fair at Ardingly again. This was only last year, and I have restored this one completely. It's all brass fittings on them. And we'll have a little close-up. It's quite a nice little crystal set, this one. Rather unusual. We have provision on this crystal set for 2 sets of headphones on the terminals here. This little bridge here is the link for, remove that and put the other coil in for receiving the long wave. Here we have a coarse control for tuning, and this one is the fine control. The aerial and earth are on these terminals over here. And of course then we have the little crystal detector. There's no instructions with it at all, but it must have been a properly manufactured one and not a kit because of the little badge it's got here with JR written on it. This crystal set is made by the Brownie Wireless Company. Tuning down here on this control, it's all Bakelite, this set, completely moulded from one piece. The badge over here, the BBC badge, and the patent number there. The manufacturer's name is written underneath the detector here. Aerial over here, and earth. And also this one has the addition, you don't have to plug in a coil for the long wave. You can get that by throwing that switch over there. So you've got the low frequency and the high frequency. The first little set I've seen with the actual switch and the coil built in. But rather a nice little crystal set, and very popular in about 1925-26 this particular model was. This is another popular crystal set made by Jackaphone, complete with the BBC stamp on it here. This is one I have restored and completely cleaned up, and it is working. This one works quite nicely. Nice to see it complete with all the instructions. The model number of this is BC 1001. This Jackaphone is the General Electric Company Limited. It was made in 1922 and it's sold for £5 10 shillings. It's in a mahogany box, nickel plated fittings, and as I said before, I have fully restored this one, cleaned all the numbers up and re-waxed them. In fact, this is done with a special wax. Once you've got all the old wax out, you just rub this like a crayon over it, and it brings up all the numbers again. But it's quite a nice example of this particular set. Here we've got the full instructions of how to operate this set. It has got the provision for adding the extra coil for long wave on the little bridge at the back there. There's a nice close-up of the detector. There we are then. That's the Jackaphone BC 1001. A very nice and very popular crystal set. Well, this is the Astrophone, made by Amplifiers Limited, made in 1923, and quite a nice little set. This is the sort of deluxe version of this particular model, and I'll show you a picture of the standard version, which is not in the Rexing case. This is like a little portable set, and quite a smart little set it is. Here's a picture of the set as it was sold in its standard form. As you can see, no case, it's just got these four little legs. Got the tuning coil here for extending the range to the long wave. Here's the connections for the headphones, and you can also run a second pair of headphones from this on these two terminals here. The very long arm with the cat's whisker at the end and the little galena crystal there, detector. The tuning is over here on this small control, and the aerial connection here and earth over there. The BBC stamp here, and also the the Astrophone registration number over there, and the post office number in there as well, which is 410. So quite a nice little set, this. There we can see the crystal quite clearly and the BBC badge. The range coil is removed from here, and we can put the little link in. So we got the shorted out. and then you're back to just the coil, which is inside here. It's tuned by the coil is across here, and this arm has a wiper which goes right across the whole length of the coil, so that's how the tuning was achieved. So there they are. That's the Astrophone Deluxe model. Right, that's the range of crystal sets, or most of them that I've got. I've got a few more which I haven't cleaned up, but that's the majority of them that I've shown you. The thing is, with the crystal set, of course, it was very, very low output, and there weren't many valves about, amplifying valves, at the time of the crystal set. If they were, they're very expensive. But what they did come out with was a rather interesting gadget, where a company called Brown come out, SG Brown, with a mechanical amplifier, which was a very interesting device. And we've got one here, and we'll have a close look at this. And this is what they used to use to amplify the crystal sets. Well, here's the little Brown's mechanical amplifier, and very nicely built, got a very large magnet over the back here, and we'll have a close-up look of how the thing works. The input to the amplifier was on these two terminals here, straight from the crystal set where the headphones would have been, and the output is on here. Now, this is claimed to drive a loudspeaker. I haven't tried it driving a loudspeaker, but they do claim in the book, as we'll have a look in a moment and see. It's virtually what it is a carbon microphone here. These two coils are from the headphone terminals here, and they have here a little reed which activates or vibrates the diaphragm on the carbon microphone in there, and it has a 6-volt battery on two terminals at the back to energize the microphone. That goes into a transformer in the base and generates a lot more current and claims to drive a loudspeaker. As you can see, it's type approved and has the official badge on there from the Postmaster General. There's the badge on the front of the box and given the serial number of 6414, made by SG Brown Limited, London. This little control here, when turned, alters the magnet over here, pushes it in and out closer and further from the reed here. So that's a sort of fine-tune adjustment on it. There's the circuit diagram inside the lid of the amplifier. As you can see, here's the carbon microphone with the granules in between there. This is a transformer, the primary and the secondary, for driving the loudspeaker. The primary windings go to the microphone. The input, of course, from the crystal set over here, and you've got these two coils which we saw next to the magnet which drives the little reed which activates this, or on the diaphragm rather, of the carbon microphone. On the lid of the box there's this little control here which has another magnet inside which alters the strength of the other magnet underneath. It's sort of another fine tuner. It says on the top here, magnet adjuster, and you just turn that to vary the strength of the amplifier signal. Okay then, so that's the little Brown mechanical amplifier which they used, and quite a nice little find, this one. Another one I found in a second-hand shop in St Leonard's. I seem to find a lot more in St Leonard's than I do in Hastings, but that's where that came from. Well, after the crystal set and the very low output, along come the valve, which made a big difference. They could actually amplify the signal then and drive a loudspeaker properly. And we've got quite a collection here of the very, very early valves, and some dating back to the first valves that Marconi produced, and we'll have a close-up look at some of these because they're quite interesting. The first valve, as I said, that the Marconi come out with is this one called the V30. Very nice valve. The V30, the filaments are made on this connection here and there. It's like a little festoon bulb. The anode on this one here and the grid there. And that's where it was evacuated there, on that part there. This was before they had a getter in the valve, so it wasn't fired and extracted the last vacuum with a getter. It was all drawn from this little tip here. But that's the first of the Marconi valves. This valve was made in 1923. This valve is the little Wico valve, also made in 1923, which has a rather unusual base to it. Again, this was a triode valve, of course, just the four connections, the filament, the anode and the grid. There we can see this valve quite nicely, the anode like a little cylinder in there, and the grid running straight the way through the middle, and the filament right through the centre of that. One of the most popular valves in 1923 to come on the market was this one here, the R-type valve. You can quite clearly see the construction of the R-type valve. The anode is the cylinder, of course, there, and inside the grid running along in there, and the filament straight through the middle of the grid. The grid in actual fact looks like just a coiled spring running straight through the cylinder there. That's come out in 1923, the R-type valve, and run for quite a number of years. A smaller version of the R-type valve was the bright emitter, and that's this one here, which is virtually exactly the same, but just a smaller version. And that also was available in about 1923 again. Another interesting valve is this Mullard valve here with the metal base. There we are, there's a label on the valve telling you the anode volts, 50 to 100 volts maximum, and also the filament voltage on there. I think it's 1.4 volts, I believe, at 0.35 amps. That Mullard valve was available in about 1924. One of the other funny shaped ones is the Cossa valve, and on the label it tells you all the details you need to know about the valve. This is the Cossa valve, HF and detector, specially designed for high frequency coupling and rectification. On the other side of the valve we've got here the filament 5.5 to 6 volts, filament amps 0.1 amp, and anode volts maximum 120 volts. And of course it's got the patent number on there. It's nice to find these valves with the original labels on them. Obviously they haven't been used, they are new valves. So that's the Cossa valve. Let's have a look at one of the other valves we've got round here. Let's have a look at this one. This is the Marconi Osram valve, the DE5. On it has got the stamp, the BBC stamp. All these valves between 1923 and 1925 had this little stamp on it. I don't think we can see it on camera, but it has the standard BBC approved valve stamp on there. You might just be able to see it. Yes, I think you can there now, just on camera. So that's the DE5 Marconi Osram valve. Another interesting valve is this one, which was the first screen grid valve made in 1927. This is the S625, two connections here for the filament. The other end is the anode, the first and second grid. That's the S625 valve, the very first screen grid valve made by Marconi. So there we are, that's the screen grid valve. Another weird shaped valve is this one here. It looks like a balloon. In fact, they call them the balloon shaped valve. This is another Marconi valve. The type number is KL1/AC/R. Rather weird shaped valve, isn't it? And it's unusual. This is the first one I have with the screen grid connection on the side. Standard 4-pin base. So that's another one of the Marconi, the sort of balloon shaped valve. Have a look at another one of these that have got the label on. Let's have a look at this one here from Cosa. This is quite a nice little valve again. It says on here, Cosa 0.1 RC, specially designed for resistance capacity coupling. Filament volts again 5.5 to 6 volts. Filament current 0.1 amps. Maximum anode volts is 120 volts. That's another one by Cosa. They seem to have changed the colour of the labels for the different parts of circuits that the valves are used in. This one being the blue one. We saw one previously with the red label on. Well, that's another one of the Cosa valves. The other valve here, which has got quite a lot of information written on it, again, is the PM22 valve. In fact, that was the part number, PM22. In actual fact, it's a PM3 valve, as it says on the label down there. It says also on here, there is practically no glow from this valve filament. So that's another interesting thing. Saves you throwing it away thinking the filament's gone. Filament volts on this one is 4 volts. And of course it's a triode again. These first appeared about 1926, this type of valve. Another weird type valve is this one over here, which is the Wico valve number 421/5A, first of the miniature type with the conventional or standard type base. Anyway, there's a bit more of a close-up of that valve. You can see it's very nice condition, this valve. In fact, you can actually read all the writing. It's not been rubbed off of this at all. So that's the little Wico valve with the standard base to it. Another interesting one is this one here, another Mallard valve, and rather a weird shape in the anode. As you can see here, the anode is in this like a little dome, and the grid and the filament of course are all tucked up inside there. I believe this is a Mallard valve, this one. The label, I'm afraid the writing of it on the side has almost disappeared. There we are, rather an unusual anode on this valve. Well, there's just a few of the valves which I have. I've got possibly, I think maybe 500 or 600 valves altogether, but These are the very early ones and the most interesting ones, but I have got them going right up into I suppose about 1960, 1970, when the last of the valves of the ones that were used in the domestic receivers were available. But anyway, there we are. Quite a nice collection and quite easily to find around the boot fairs and various other places. Keep your eyes open for them. I'm always wanting more. Some of the other interesting things I've collected in my roaming around looking for radios and things are these bulbs and Berettas and various other bits of glassware, which I thought you might be interested to see, as they're quite fascinating and they do date back quite a long way. The first one we'll have a look at is this rather weird looking object, which it claims is a dummy load. It's obviously a government device because it's got the little arrow on here with a military number on here. The thing is constructed of, has these five pieces of mica inside with the filament or the wire wound round them, as you can probably see, and it's a dummy load. It says on here Atlas 100-watt dummy load. There we can just read that it says on there dummy load 100 watts Atlas. There we can see the construction of it a little bit better, with the element wound round the mica. No indication to what impedance this device is. It has a standard 4-pin base, the same as what the valves have, the early type valve, so it dates back a few years. When it was used in the war time somewhere on some piece of equipment. It'd be rather interesting if someone knows exactly what these were used in and where. This is an interesting one, this neon bulb. It has 2 plates across there, which one on each conductor, and we'll light this one up in a moment and see how it glows. There we are, we can see the construction of it a little bit better there. Clearly written on the bottom here is property HM government. There we are, quite a nice healthy glow from this neon. I've no idea how old it is, but just one of the odd things I've collected. Well, there we are, that's one of the neons. The other neon I have is rather an odd shaped one. Is this one here, made by Siemens. As you can see, it's rather an unusual shape, this one. Has this rather large dome. Quite interesting to see what this looks like when it's lit up. On the other side, turning it up the other way, because the writing's round this way, it has Dobrulux, D-O-B-R-U-L-U-X, written on the side there. And of course it's Siemens, 200 to 240 volts, 0.4 to 0.7 watts. So it doesn't consume a lot of current. Let's light this up and see what this looks like. It's got quite a fascinating effect, this one. It seems to be chasing itself round and round that dome. Quite a pretty display. No idea what it was used for, or what its intention was, but quite fascinating to see it operate. Well, that's the Siemens neon. While we're talking about bulbs or showing bulbs, This is rather a fascinating one, a very, very early one, light bulb. This is quite an early one, as you can see, because it's got this little pip top to it there where it was evacuated, and it's a carbon filament of about 3 turns and about just over ½ inch diameter. So there we are. That's one of the very early filament valves, which filament bulbs rather, which I have. The next one of interest is probably going to be this one. While we're talking about bulbs, complete with its box. This is rather an unusual one. Multiplex, the lamp with 2 distinct lives. Gas filled. What else did it say on here? The security of a name is May. British products, fully guaranteed. Let's have a look at this bulb. There we are. A very, very nice box, all in its original condition, this. So let's take it out and see what we have here. I don't think these bulbs ever come onto the market, because I've never seen one before, and it's most unusual. As you can see here, it has 3 contacts with a standard bayonet cap, and the 2 filaments inside. As you can see, it says 40 plus 40, so it's 2 40-watt filaments inside this bulb. There we can see the 2 filaments, both intact, and I think this bulb is absolutely brand new, all in its original box. When one filament burnt out on this bulb, you just actually slid the outer ring round until it fitted into the bulb holder and made contact with the other side. So you had one common contact on the top here, and the other 2 around the other side there. And you can see how you could get the other filament to light then by turning the rim round where the 2 little posts come opposite the contact that you wanted. Well, there we are, another interesting bulb. I don't think it would have come out into the market too long before some other manufacturer of bulbs with a single filament in them bought them out and got rid of this product, because if it lasts twice as long, or you got twice the use out of it, and it didn't cost twice as much, there would be a problem there, no doubt. So quite an interesting one, that. Well, the other bulb I have of about the same era, I should think, is the standard coiled light bulb, coiled bulb, again with the little pip top, so it does date it with the ordinary standard BC base, but nothing too special to say about this one. There we are, just an ordinary standard light bulb, not a lot different to what we buy today, except that, as I say, it's got this little top to it here, which definitely dates it. Well, there we are, that's the other light bulb. The next one we have is a similar to construction to the one we saw just now, which was this one with the large filament. This also has a very, very large filament in it, but a different base, of course, the large Edison base. This one is very, very dark, the glass on this, so I'm not sure if that's through burning or what, but it's one of the old carbon filament type lamps, as you can see, with a rather large coil in, about 1 inch diameter and about 5 or 6 turns. So there we are, that's another one of the light bulbs. The next one I have in light bulbs, which I believe is a light bulb of course, well it should light up alright, is this huge great thing here. God knows what it was used for, but could have been an ordinary outside light I should think, but quite a big construction filament inside. As you can see, quite a large filament. It's 30 volts, 5 amp, this particular lamp. So there we are, a rather nice bulb, quite large. The next one I have is bigger still, is this monster we have here, which is 230 volt, 400 watts. There we can see the construction of the filament. Well, there we are, that's the 230 volt 400 watt Osram lamp, which is quite a nice one. This is another lamp, but just a larger construction, don't know much about it. I don't think there's any writing. Oh, well, there is some writing on this. It says Osram 230 volts 500 watts, this one. Not a lot of different from the other one really, but just fascinating. These of course are not lamps but Berettas, which of course were used in the radios. These were used in radios in series with the filaments. It's extremely fine wire inside there, and these were obviously used on the AC/DC sets. It has a standard Edison screw base on there, and the writing on the top here is Osram, and I believe it gives you the resistance of this device. This is the Osram 301 Beretta. We're trying to do a close-up of the filament just to see how fine it was. There we can see how fine the filaments are in this, well, the one filament, and of course they broke quite easily, these things. So well, there we are, there's one of the Berettas. We've got a brand new one here, which I found all in its original packing, Beretta Type 301. Here we are, the GEC Beretta Type 304, specially designed for use with GEC 0.3 amp universal range valves. Absolutely brand new. Similar construction to the other one of course, but not quite such fine filaments in this one. The other Beretta we've got is this one here, which is made by Tungstrom. There we are, the Tungstrom 108R, and this one's all intact as well. Same base, it's a 3-pin base on this rather, bit different. Looks like it's had the 4th one in there, but they've chopped it off for some reason. Obviously didn't need it, as there's only 2 connections to the Beretta. So that's the Tungstrom 180R resistance, and that's all intact as well. Last few things, this is a rather interesting little device, this little tiny little thing we have here, which is a battery fuse for battery cord. There we are, 2 connections, little tiny glass device, very similar to a bulb, and it was the fuse for the battery sets. There's a very early torch bulb. You can see the white part of the base there and the clear top. This one's still got its filament. dates back to the 1930s, I should think. There's another very early torch bulb. I haven't got too many of these, but just enough to say that I've got something in the collection anyway. Right, there we are then. That's part of my collection of various types of lamps and Berettas. So we've got quite a nice selection there, but I've got a lot more than this, but it would take absolutely ages to go through them. So if you find any of these about and you don't want them, I'll be very glad to take them off your hands. Well, another part of the hobby of collecting has been these meters, which we've come across, and I'm glad I bought them now because I've got quite a good collection here. I have borrowed one or two from a friend just to supplement the display, mainly of multimeters which he collects, but mainly all the little pocket meters which I've collected have been found in the local antique shops and boot fairs and places. They range from about 1911 is about the earliest one I've got, up to about 1942, I think, the multimeter over the back there. And most people had a meter in the early days, because you must remember that they had, with the battery sets, the accumulator and the high tension battery. And without the aid of a meter, they couldn't tell whether it was the accumulator gone down or the HT battery. So a lot of people purchased these little tiny meters. Pifco was the main brand in those days. But then they added extra facilities, not only for testing the HT and LT batteries, they also made them where you could test the filament of the valve as well. And so, as I say, most people who had a set in the early days had one of these little test meters. So we'll have a close look at some of them now and see some of the most interesting ones. We can't show them all because we'd be here for another 2 hours, I should think. This is one of the most common type of meter. It's all Bakelite and has two ranges. The common lead is this one here, and of course, being a moving iron meter, doesn't matter if it's AC or DC, hence the AC and DC signs here. This range on this one, on this probe and the common, it's up to 8 volts full scale deflection, and on the top range, on the other probe there, is 160 volts. Made of Bakelite, quite a common sight I should think in the very early days. Nothing too pretty about this one, a very, very basic meter. This one's a little bit more of the upper class. It's actually a moving coil meter, made in France, and has two ranges. This time it only has a single probe here, but it has two wires, the red and the black. So you have the red for the low scale, which is 0 to 8 volts.